At Tesla's Investor Day, the company made a shocking revelation. Going forward, they will make new electric motors for their cars that would not require the valuable rare earth element. How will this change affect electric cars? What will they use instead of rare metals? In a shocking turn of events at Tesla's highly anticipated Investor Day, the pioneering electric vehicle giant delivered a bombshell announcement. Their upcoming generation of permanent magnet motors will break free from the clutches of rare earth. This news caused a big reaction in the market. The stocks of Chinese companies that mine rare earths dropped a lot, with some falling by as much as 10%. In Australia, the largest producer of these important metals that's not from China, called Lynas, saw their shares go down by about 11% when the trading day started. MP Materials, a company that mines rare earths in California, also suffered a big drop of around 11% because of this announcement. Rare earth are often referred to as the nutrients of the industry. Although we require them in small quantities, they're sprinkled throughout our most cutting-edge technology. They fuel our smartphones and computers, reside within wind turbines and hybrid vehicles. They even find their place in dental implants, X-ray machines, and life-saving medications for cancer treatment. These elements possess extraordinary magnetic and electrical properties that amplify the speed, strength, and lightweight nature of our devices. We've been riding the wave, reveling in the enchantment for quite some time now. In fact, we've grown accustomed to this spellbinding effect, and yet little is known about this mineral. So what exactly is this rare earth? Rare earth elements are plentiful in the Earth's crust. However, the challenge lies in their low concentrations in minerals. Even when they're discovered, it's difficult to separate them from other elements, which is why they're considered rare. Interestingly, these elements may also be called rare because they're not commonly discussed. Despite playing a huge role in various technologies, everything from iPhones to Tesla electric engines rely on the utilization of this mineral. For you to have a better understanding of how important they are, let's start by classifying rare earths into two distinct categories based on atomic weight: heavy and light. But what's fascinating here is it's often the heavy rare earths that garner greater attention and demand in the market. But then again, it'd be negligent to underestimate the importance of light rare earths. These elements, although lighter in atomic weight, contribute significantly to technological advancements. A prime example of this is the application of neodymium and praseodymium, which fall under the light rare earth category. These elements are specifically utilized in the creation of rare earth magnets, known for their exceptional strength and magnetic properties. Despite being classified as light rare earths, neodymium, praseodymium, and other elements found in rare earth permanent magnets, such as dysprosium, command considerable prices in the market. Their scarcity and unique properties make them valuable components in various industries. Of late, neodymium and praseodymium have captured considerable attention and excitement due to the rapidly growing electric vehicle sector. The amount of different rare earths found in each deposit can vary, and usually a deposit is mostly made up of either heavy or light rare earths, with some elements being more abundant than others. Not to be underestimated, rare earth has been the cause of diplomatic tension, with the Chinese calling the shot. The Chinese grip. China presently holds a firm grip on the rare earth elements market, commanding an 85% share of the global supply in 2016. Australia follows as the second largest producer, contributing 10% to the market. However, despite Australia's efforts, it's made little impact on China's monopoly. To put things into perspective, in 2018, China produced a staggering 120,000 tons of rare earth, whereas the United States, in comparison, produced a mere 15,000 tons. China's also employed rare earth elements as a means to pressure other countries. For instance, in 2010, China stopped exporting the mineral to Japan as a form of punishment for detaining a Chinese captain. China's also contemplated reducing rare earth exports to the United States in response to tariffs imposed by former U.S. President Donald Trump. This situation posed a significant threat since the U.S. defense sector heavily depends on these minerals. However, it's worth noting that China possesses only 35% of the world's REE reserves, which raises concerns about how the country has managed to gain a monopoly in this industry. Now that we've registered how valuable this mineral is to the political and tech sector, I'm sure you're probably wondering, why on earth did Tesla pull the plug on them? Expensive and environmental factors. It's to nail a particular reason Tesla chose to ignore rare earth, But the major one that stands out could be the fact that the minerals are expensive. The cost primarily stems from two underlying factors: the rarity of these minerals and also the angle of mining operations becoming more expensive due to the substantial amount of dirt and rock that needs to be meticulously sifted through to reach the precious rare earths. The additional effort significantly drives up the cost of extraction. From the ridiculous cost of production that comes with it, there also lies the challenge of environmental devastation. There are two main methods used for mining rare earth elements, but unfortunately both methods have detrimental effects on the environment. These processes involve the release of toxic chemicals that pose serious risks. The first method involves removing the top layer of soil and creating a leaching pond. In this pond, chemicals are added to the extracted earth to separate the metals. While this chemical process is effective in dissolving the rare earth minerals and concentrating them for refinement, it comes at a cost. Leaching ponds filled with toxic chemicals can pose a threat to groundwater if not properly secured. In some cases, these chemicals can even contaminate entire waterways, leading to significant environmental damage. The second method involves drilling holes into the ground using PVC pipes and rubber hoses to pump chemicals into the earth. Similar to the first method, this process creates a leaching pond with the same issues. Unfortunately, PVC pipes are often left behind in the mining areas, contributing to long-term environmental pollution. Both of these methods result in vast amounts of toxic waste, which poses high risks to the environment and human health. For every ton of rare earth produced, the mining process generates approximately 13 kilograms of dust, 9,600 to 12,000 cubic meters of waste gas, 75 cubic meters of wastewater, and 1 ton of radioactive residue. One of the most concerning aspects is that rare earth ores often contain radioactive elements such as thorium and uranium, which have severe health implications. This further compounds the environmental and health hazards associated with mining and refining of rare earth elements. Astonishingly, for every ton of rare earth produced, a staggering 2,000 tons of toxic waste is generated. Seeing the severe environmental impact and the high costs involved in mining and refining rare earth elements, it becomes understandable why Tesla and other companies might choose to pursue alternative solutions. And what exactly could these alternatives be? The ferrite alternative. Now, Tesla hasn't specifically spelled out their replacement for the rare earth material, but experts believe that the material called ferrite is the top choice to replace the rare earth. Ferrite is a material that's been widely used since the 1950s, as it's inexpensive and easy to manufacture. The mineral has already been used with relative success in motors, proving it's a trusted and reliable option. In the second generation of a powertrain used by General Motors in their 2016 Chevy Volt, they had two types of motors. One of them used ferrite magnets, the other used rare earth magnets. Not to be outdone, Protereo recently showed their own designs for electric car motors. And guess what? They also use ferrite magnets in their designs. But here's the deal. While it's been shown that a motor using ferrite magnets can perform just as well as, or even better than a motor using rare earth magnets in terms of certain aspects, there is a drawback. The ferrite-powered motor tends to be significantly heavier or less efficient, which has made the switch less appealing in the past. In one of the new motor designs by Protereo, they created a simulation of an electric car motor using ferrite magnets. This motor matched the power and maximum rotation speed of a similar motor using rare earth magnets. However, there was a problem. It was 30% heavier than the rare earth-powered motor. This weight difference is quite significant and is considered a major disadvantage. In another design created by Protereo, they simulated an electric car motor using ferrite magnets that had the same power output and motor weight as a similar motor using rare earth. However, the ferrite-powered motor operated at a 50% higher rotation speed. This increase in rotation speed resulted in a decrease in torque, which is an important factor in determining the motor's strength. When it comes to motors, Tesla is always focused on finding the right balance between cost and performance, an area where motors powered by rare earth have excelled. That's why it's surprising to see Tesla's abandonment of rare earth based on anticipated supply scarcity and concerns about environmental and health risks. But then ferrite isn't the only option that's being explored. There's another that exists, an option brought to light by the company Nitro, the Nitron option. Nitron claims to have developed a magnet based on iron nitride, which they say is theoretically even more magnetic than neodymium, the rare earth metal used in EV. However, this material is quite challenging to work with and keep in a desirable form. Andy Blackburn, the EVP of Strategy at Niron Magnetics, mentioned that they're making progress but won't be able to produce magnets powerful enough for Tesla's next generation of vehicles in time. According to Blackburn, the first step for Niron is to use these new magnets in smaller devices like sound systems. This means that they're starting with smaller applications before they can develop magnets strong enough to have a significant impact on electric vehicles like those made by Tesla. The VP of Tesla also had this to say: "You get a new commercial magnet a couple of times a century," emphasizing the rarity of advancements in magnet technology. Blackburn and other experts in the field are speculating that Tesla might have determined that they can work with a less powerful magnet for their upcoming vehicles, the most likely option from the few available being, of course, ferrite. While we're left to ponder on Tesla's resolve to abandon the much-wanted rare earth, we can only anticipate what the EV company is going to choose as an alternative going forward. Thanks for watching. Until next time.